Hi all. So in today's video, I'll be explaining you guys how a linear regression works. So as you can see, linear regression is nothing but a statistical equation, which we might have heard in our school days, like y is equal to mx plus c. The only change is we were calculating this slope and bias using matrix multiplication, but with big data it is not easy to estimate or consume full data into matrix multiplication, so it makes sense to train this model via iterations. We call it epoch in machine learning, and here your slope is replaced by a weight matrix. Okay, so you can see this image where you have some data points y and x. So I'm just using one variable here, but in actual you can have multiple data points, and red line is the one which we are trying to train using linear regression, and the black lines which are connected is actually the error, or you can say loss. Okay, so we'll see how this is actually calculated. Okay, so x is your feature space, which is, let's say, x1 x2, how many variables you have, and y is your target variable. In case of regression problems, your y is a numeric or continuous variable, and weights is a matrix because it is equal to number of variables or features you have. And you have a bias term also, because if there is an intercept in your equation. So we initialize this equation with some random weights and bias. So let's say you have this red line, it might be here in the start. Okay, and then we calculate these losses from each data point. Okay, and let's assume in this case we do it using mean square error. This is the loss we are using. Then we use an optimizer, let's say gradient descent, to make adjustment into the weights and bias, and the objective function of the optimizer is to minimize the loss. Okay, so every iteration we are doing some weights adjustment and bias adjustment, and let's say we run the model for 100 epochs, and then we measure the r square value. uh, R square value is just the variance explained in the model. Okay, so if it is close to 1, our model is good. If it is close to 0, our model is bad. If it is exactly 1, then there might be a chance, I believe it's strongly a overfit model. Okay, so depending on your problem statement, you can adjust this r square value by training a multiple number of epochs. Okay, so this is how we train a linear regression model. Thanks for watching, guys. Do like the video and subscribe to my channel.